what it would be in like a average household or factory?
The pressure that's going to the engine? Yeah,
the pressure line.
The primary regulator takes the cylinder pressure from the tank at 2,000 psi and regulates it down to about 10 psi.
Which is what you would see, or?
No, which is what I feed the secondary regulator, which is a low pressure regulator, which knocks it from the 10 psi from the cylinder to 2 inches of water column, which is about 1/15 of 1 psi.
1/15 of 1 psi. It's tiny.
2 inches of water column, and that was typical of the pressure that was in the illuminating gas pipeline that fed the houses and industry back in the mid-1880s. And everything on the engine, as far as valving and orifices and everything, is sized to run on a fuel supply pressure of that amount.
So then it comes and it fills up the bag.
I'll show you. Open the cylinder up. This, and you'll see the meter move. The gas will flow through it.
Yep.
It's at about 2 inches of water column pressure.
Okay.
The bag is inflating.
Yep. This is the accumulator bag?
Yep. Yep. That's to take the pulses out of the gas flow.
Because it might pull more than the line can supply.
It's the 1/2-inch line is feeding it, or 3-inch line is feeding it. Every time that the engine ingests a charge of air and fuel, it'll actually, without this accumulator in there, it'll pull the pressure of the supply line down from the street that's feeding it, and any lights that are in the buildings that run off the
all go out.
Can go out. Yeah.
So that comes in. So is this the main control valve for feeding the line to the cylinder?
This is
for everything?
This is the main shutoff valve down here. It
okay.
shuts off
to the bag, right?
To the engine proper. And this is the valve that you turn this way. It's at off now, and you can see that the scale from, I think it's 0 to 10, and those are just arbitrary numbers. That basically it goes from 0 is off and 10 is like 90 degrees open.
Mm-hmm.
And this controls the actual fuel to the engine burns. So that controls the air fuel mixture of the engine.
Okay, so
you have a T here, and then on the other side of the engine, which is fed by the same 2 inches of water column pressure, the gas comes over on this side, and this is just a support. It doesn't go into the cylinder, so it just splits here with a T. This valve is the source that you control. It goes inside the engine into the slide valve and controls the
internal flame.
Yep, the internal ignition flame within the slide valve itself. And this valve, you follow the pipe around, goes to the front of the engine and lights
external flame.
Yep, it's your relight flame that relights the internal flame every cycle the engine runs, because the internal flame extinguishes after it does its job to light the charge in the cylinder, and it has to be relit. So when the slide valve cycles up and down, the window inside the slide valve thickness that has the hydrogen source gets relit by this external flame.
Now, does that little conical member, does it have a little hole at the top? That's where the hydrogen comes out?
It's a little hole. So
okay.
it's
just a little tiny hole.
11 thousandths in diameter.
It's tiny.
Yes, it is.
So we just opened up the valve to it, and
we'll keep talking. I'm just letting it purge some of the air out of
it. It's literally from last time.
Did it make small flavor rices?
I'll make one.
Yeah. 3?
Yeah.
So air can get in the lines when you're not using it.
Yeah, if the machine's down, the system's going to be full of air, so you want to try to purge out what's in it. And really, the right way of purging it out is just without any flames on. You turn the gas on, and it's just venting out right now. And I know that the bag takes 2 cubic feet of 0.2 cubic feet of gas, so 2 wraps around my meter means that I've basically pushed out the volume of the gas bag.
Yeah, you can see the gas bag.
Yeah, and I'll shut it off. It should start to reinflate a little bit.
How come you want to purge the system?
To remove any air out of the gas bag.
Because air and hydrogen's bad?
The ignition can back feed through the pipe if you have an explosive mixture in it and go back into the gas bag.
Now, do any of these engines come with a spark arrestor?
No.
Okay. Was that not a thing that was around in that day?
Wasn't even considered. No. I've made flash arresters before on other early engines to prevent backflash, and it's not a big deal. I mean, you can take a piece of a sintered bronze sleeve that you can put in the fuel line. Basically, all you're trying to do is find something that will quench the flame as the flame tries to pass through it. The object has a mass that it can't heat up, and if the flame gets quenched by the mass of the metal, it shuts it right off, and the flame will propagate through it.
That's pretty cool. So, as you can see right here, this is usually the water lines that come in. It's hooked up to the water tank.
It just haven't been installed yet because it hasn't been built. But water inlet is in the bottom. It goes into a water jacket, which is in the bottom of the cylinder head, surrounds the cylinder, comes out the top of the water jacket, and it goes back into the tank. So the tank level would be filled to a point above the upper water port, and just by convection, the water will flow as it heats up. It'll rise, go into the tank. It'll cool, go down. Yeah, you have thermosiphon, convection cooling.
Yep.
And it doesn't need much. The engine can run for hours and not really warm up that much.
Yeah, well, we felt it when it was running today. Even under that load, it didn't heat up that much. So what is the process now of actually getting it lit and running it?
Well, lit and getting run is fairly straightforward.
And do you usually have to lube up all the bearings and the gears and everything beforehand with oil?
Absolutely. I'm going to do that right now.
Okay.
And these early engines did not have any provisions for continuous oiling. So in order to properly lubricate the engine, it all had to be done by hand. So all the surfaces,
Both slide valves.
yeah, both slide valves. The slide valves are very finely scraped and lapped and fit, so they need oil all the time. Plus, the slide valves are made out of cast iron, and when you burn hydrogen gas, all the exhaust gases are laden in water vapor, because water, free water and water, liquid water, because that's the result of burning hydrogen in an engine. So you want to make sure they're oiled to prevent rust from occurring on all the precision sealing surfaces of the slide valve.
And all these have oil port holes.
Yep, and oil caps. You just squirt some oil in. You should do it periodically as the engine's running. And it's a lot of oil, a lot of wear surfaces on the engine that you want to lubricate. And this part up here is just it's a sliding guide, which is bolted to this part here, which is the rack gear. And this guide slides up and down and makes sure the rack gear stays engaged to the gear on the directional clutch. The clutch is what transfers the energy from the rack to the main shaft.
Which in turn turns the flywheel. And what do you call this? Is this, because you got the flywheel on the other side, this is what drives the belt?
Yep, that's just a flat belt pulley, correct. And that's would be coupled up to a line shaft or whatever the engine would power. Alright, so the gas for the engine is off. The ignition flame itself should be on. You should hear a little bit of a pop on this lights.
A little bit, yep, see
And
it.
if you look at it, you might be able to see the flame.
A little bit.
But hydrogen, in its pure form, is almost invisible. With any impurities in the air, sometimes you get like a little bit of a spark in the flame or whatever.
So, and hopefully this flame stays lit the whole time.
Yes, that's the intent. And now what I'm going to do now is light the internal slide valve flame by opening this valve. And if you look into the passage in here, you'll see a hole in there, and it'll light. You'll hear a little bit of a pop, and the flame will come out, and I'll try to find adjustment where the flame is not that big. Okay, now you can see the flame inside and the flame outside. And as the slide valve goes up and down, that internal flame gets transferred into the combustion chamber through a port. And just before it goes, communicates with the port, the flame becomes trapped. So it's completely sealed between the slide valve cover and the engine. And that way the combustion gases can't escape.
There's a point in time where it's traveling up with the slide valve that it doesn't even have, it's totally isolated.
Totally isolated, yep.
It's like a fire in an elevator. The door closes, the elevator's on fire, it goes to the second floor, the door's open.
Yep. And it stays lit in that short amount of time. Yes. So with this fuel line that's coming in to feed the actual the cylinder, on this one it's got the secondary slide valve, which is just a safety mechanism.
Yeah, this is a safety mechanism. So when you rotate the engine, the piston comes up about 5 inches, and that's the duration of the intake stroke. There's a lever on top of the engine which shuts this valve, turns the valve down, which the port shuts this fuel off. The fuel comes through that valve, through here, through this valve, just does a U-turn, comes back out, and this goes into the engine.
Now on the later models and the Deutsches Museum one, it doesn't have the secondary slide valve.
Doesn't have it. The engine was probably built just after they discontinued it. The boss on the slide valve cover is there for the slide valve, but it was never machined. As is a boss on the top of the engine, which supports the bracketry which drives this.
Right. Now, so the one in the Deutsches, it's still got the gas lever, and then it just goes directly to the side.
Yeah, the gas valve is actually on this side, and it goes directly into the side of the engine. It just does not have this extra valve on it. It's probably a result of a cost savings measure or some simplification of the design.
Sure. So now it's pretty much ready to go, and we got all the gas feeding, so we can go ahead and start it up, right?
Yes. Yes. So all we're going to do is we're just going to open this up to a part where the engine is usually pretty good.
The reason it stops is because the governor came down, shut it.
Yes, as the engine speeds up, the governor weights swing out. When they swing out, they pivot on the pivot point, and this rod goes downward. When it goes downward, it closes off the flow of exhaust gas through this check valve. It deadheads here, and it can't go out the rest of the engine. And when this valve is closed, the piston can't come down all the way because it prevents the exhaust, traps the exhaust.
It's the back pressure, right?
The back pressure, exactly. So when the engine slows down, the governor weights go from their outward position down. This valve opens up and the exhaust gas can go out. And you can see it up here also. When the engine fires, the engine will go up, it'll come back down. And right now, the rack and piston assembly can't come down because that valve is shut. So you'll hear, now you start hearing the gas to rush out. When it does, it trips this arm right here. You'll see this arm to the right. There's a boss on the side of that rack gear, which now it's coming down coming down. Lowers this lever. You can watch it again next time it does it. When it does, the pawl releases, and the hook of the pawl engages the ratchet. It drives the eccentrics one revolution.
And the eccentrics then go in turn and pull the rod for the slide valve up.
Yep, two things happen. The first thing that happens is the right eccentric, the main eccentric, lifts the piston and rack assembly up, and when it picks that up, this right eccentric, which is connected to it, cycles the slide valve down here, and when it does, as it picks the piston up, the slide valve goes down, aligns the intake fuel port, lets a charge of air and fuel in at the same time the piston and rack is being lifted up. At the top of the piston's travel, at the end of the intake stroke, the slide valve returns in its downward position, upward, and that's when ignition actually occurs. So as the piston goes up, the piston goes down for intake and fuel. and the piston finishes its upward motion, the slide valve goes up, and ignition occurs.
And then seen in the position that it's at right now, it's actually in its exhaust state, right?
That's exactly right. It's in its exhaust state, which is in the middle of the travel. And the middle of the travel is where it's stationary.
And the reason that the piston can still come down and deliver power to the flywheel is because the check valve isn't letting the air out, or the negative pressure.
Correct. It prevents the atmosphere from rushing backwards through the exhaust into the engine.
You remember from yesterday.
I do. I'm actually learning things here.
And so that kind of explains what's going on this part of the engine. As the engine spins, the main shaft and the auxiliary shaft always spin. The part that's intermittent are the two eccentrics on the shaft. Just the eccentrics are intermittent, and it's controlled by when this ratchet and pawl assembly get tripped solely by the position of the piston. So the piston has to complete its cycle, come down when the governor says it's slowing down, trips the pawl and ratchet, and cycles the eccentric for exactly one revolution. Slide valve goes down, lets air and fuel in, slide valve goes back up, ignites it, and that happens simultaneously with the piston being drawn upwards.
Now, the boss that can be seen on the left-hand side that drives that secondary slide valve, that's not even in use in the Deutsches Museum 1.
Yes, good point. The boss on the Deutsches Museum engine is on it, but that feature was omitted.
Because the whole secondary slide valve.
The whole secondary, I mean, you'd almost think, well, it was lost, but the castings were never machined to accept it. So it's, for whatever reason, we probably don't know the whole reason why, but that engine does not have that feature installed. The boss on the right side of the rack works the trip for the pawl, and it's also the same part which the lifting eccentric reacts against when it lifts the rack and piston assembly for the intake stroke.
So can we talk about how power actually gets transmitted to the flywheel from the piston then?
Absolutely. On the back side of the engine, you have a sprag clutch, which is a series of rollers and wedges that allow the reciprocating motion of the rack to get transmitted through the pinion gear and the clutch to the main shaft. When the engine fires, the piston shoots upward. This gear spins a counter rotation to the engine. So the clutch allows just to slip, and the downward stroke of the piston, the clutch shoes align and let the energy get transferred from the inside of this ring gear to the main shaft. And the thing I didn't mention before on the Otto Langen engine is the power stroke on this engine is derived from the atmospheric pressure pushing the piston back down. When you have ignition, you'll see the ignition drives the piston upward. The clutch gear spins backwards from the direction of the main shaft because it's just freewheeling. When the piston descends, the hot gases of combustion in the cylinder cool off, and the piston rack assembly come down rapidly as when the clutch inside the gear engages the shaft. The clutch was designed in 1867 by Franz Rouleau, who's a German kinematic engineer. The Sprag clutch, as we know today, was invented just for this engine. So its lineage dates back to the 1867, 1866 time frame when the engine was made.
The way you described it to me yesterday, it's kind of like the starter on lawnmower. Works on the same principle.
Yeah, the rope pull on lawnmowers and chainsaws are a smaller version of the same thing. So when you grab the recoil, it engages the shaft, but once the engine runs, it can continue on with and be independent of the recoil.
And so this is the main shaft, and then this is the gear on the main shaft that delivers the rotation to the auxiliary shaft.
Yep. Main shaft, the way it's set up right now, which is a little slower. Originally, the main shaft was designed to run about 90 RPM. It's running about half that speed right now. The drive gear on the main shaft has about 10 teeth less on it than the auxiliary shaft, and that's to keep the speed of the auxiliary shaft slower. So when the ratchet and pawl assembly and the eccentrics on that energize, it's going at a slower speed and there's less impacting energy on it.
So you said it spins slower for the eccentrics?
Yeah, for the well, it's to keep the impacting energy minimized when the pawl engages. It's an instantaneous event, and the slower you spin it, the less impact energy you're going to have on it, and prevent things from breaking or shearing.
Sure.
And
So
they go with a speed increasing gear set on the flyball governor to get the speed back up again fast enough that it will actuate properly.
now, you know, if you slow down the eccentrics, that also obviously slows down how the slide valve moves. Is that pretty touchy?
It's not a problem when it's running at 90 RPM, which is twice the speed. It's not a problem at all. There becomes a point you get down around 30 RPM, the slide valve doesn't cycle fast enough for the carrier flame ignition to function properly. We talked about that dead period where the flame in the slide valve is trapped from the outside environment and the inside environment. It will actually be extinguished because the time period for it to travel from the outside environment to the combustion chamber takes too long. So the engine needs to run, you know, about 35, 40 RPM at the slower end, and its upper mechanical limits, the slide valve flame system won't reignite itself about anything above 120 RPM.
I think that pretty well covers it. I think the only thing I didn't mention is this little, just a waste chamber for all the exhaust and all the goop that comes out of it.
Yep. There's a. This is just strictly a exhaust pot, and if you look inside, there's just emulsified oil and condensation, which you get from burning the hydrogen fuel. Now, the other thing I didn't mention too is the slide valve system on this engine. The surfaces are machined, then they're ground relatively flat on a surface grinder, and then they are hand scraped with a carbide scraper, and you use a granite surface plate and bluing, and they give witness marks on it, and it's a long involved process, and it takes many iterations of scraping to get it exactly the way you want it, but you end up with a perfectly flat surface, which is flat 50 millionths over the whole length of the slide valve. And that gives you a perfectly gas-tight seal that allows the pressures of combustion in the cylinder from escaping. The combustion pressures on the Otto Langen engine are about 75, 80 psi or so the slide valve has to be able to contain that. Plus, the other benefit of the scraping marks, if you look at the front, you can see the texture, the irregularities on the surface of the slide valve. And you may look at that and say, well, that doesn't look too good, but it's actually very important because it contains the oil film, which is a very thick oil film on it, and the oil film seals. It's its primary function, and the secondary function is to lubricate the valve so it doesn't wear. So the technology of the leak-proof slide valve system on the early engines was developed just for the early gas engines. You contain the heat of compression, the heat of combustion, ignition, and higher pressures without leaking anything.
And so, what's the purpose of all these springs right here pushing down on the slide valve covers?
So the springs, what they do is you have a stack up of components here. You have a engine frame which has holes drilled on it, which are exposed to the backside of the slide valve, and depending on the position of the slide valve, allows those ports to communicate with either exhaust or fuel or air. And then you have a cover which holds the whole assembly together. So you've got this spring-loaded sandwich, which is completely gas-tight, and the springs allow a controlled amount of pressure to keep the sandwich tight, so none of the gas can bypass those passages and go behind the valve and escape outwards. And the same thing with this. This is a smaller slide valve we talked before, just for the fuel valve, which shuts the fuel off on the engine every time the piston is lifted more than 5 inches. It's also a safety device too on some of the Otto Langen engines that exist today, if the engine was spun over backwards, the clutch will actually engage the piston and pull the piston up to the top of the cylinder, and it could potentially draw on a very large gulp of air and fuel. And if the ignition flame happened to be turned on, you could blow the engine up. That happened on a few of the engines that survive today. So it's a nice safety device, and the only engine today that actually has that installed as built is the Kinzer's engine. Although serial number 1 in Germany had it built on, it was installed in it when it was built new, but it was removed sometime in its history, probably when it was installed at a small workshop in Paris. It was sold in 1867 after its introduction, and there's some notations in the journals that the machine was serviced a couple times, and they probably simplified it, said you don't need it. So.
Can we maybe show real quick what happens when this thing comes under load?
Yeah, absolutely. Let me just speed it up a little here for you.
Yeah. Adjusting the governor.
Yeah, definitely governor doing it a little more speed.
We're getting up more near 80 RPM.
Yeah, a little bit more speed. And what we'll do is we'll put a little bit of resistance in the flywheel, and the governor will allow rapid descents of the flywheel, or the piston, and rack assembly, and it will fire more often. And you can hear